Hello, my name is Daniel, and I'll be presenting my FPGA-based Quadcopter control project. The goal of this project is to show how an FPGA can directly drive a quadcopter by interfacing with its electronic speed controllers, sensors, and RF communication device, while receiving commands from an Android phone app that I developed. So the milestone for this part 1 demonstration video is to show the implementation of the communication between the phone and the system, which responds to a command from the phone by turning on the motors or turning them back off. But I have not implemented the sensors yet. So to get started, the system diagram is basically, this is the center of the design for the quadcopter, and essentially the components are the FPGA, then the sensors. This provides feedback such as orientation or acceleration data, an RF device which is connected to the FPGA, which enables wireless communications with the Android phone, and finally the USB connection to a PC, which is just being used to debug. So then my top level design here for the HDL module, then there's 4 input signals and there's 6 output signals, but my top level module contains 2 submodules. So in this case, the clock essentially synchronizes all operations within the this I will call it flag controller. Then the reset signal will restart the system. Then the serial RX signal basically tell the system that what commands are being listened to. So the and then the button signal is basically just just a little testing button that I can print something to a serial monitor if I want to make sure that there's a proper connection between the FPGA and the computer. So then the submodules include basically the serial UART module. This handles the serial communication, and then the ESC driver module, which generates the PWM signals required to control all 4 ESCs. The outputs again are just the serial out, which is a TX signal, then an indicator LED, which powers on when the state of the motors are on or spinning, and then powers off when the motors are not spinning or in the off state. And then the 4 ESCs that will drive each motor accordingly. So the implementation of the communication that has been successfully established. So first I will press connect from my phone, and this will establish a connection with the drone. So once the connection is successful, then I'm able to begin driving the motors. So when I press start, the motors begin spinning, and when I press stop, the motors stop spinning immediately. And then the LED indicator also reacts to these commands. Maybe it's a little bit hard to see, but the button that essentially will be doing is just printing a small message to the serial monitor on my computer, which is just my name. Thank you.